Hello, this is Patrick Parker, and I was just going to give a quick demo of EmpowerID's implementation or of Mission. I've been working or collaborating with Karl McGuiness and on the mission framework to control authorization for agents. And our side of the equation is really connects with mission, which is the governed execution. And the two together, mission decides what are the boundaries of what should this agent be doing in this case? What is the goal? What are the boundaries? And then governed execution monitors and controls the execution to ensure that what was executed was the same as what was approved, down to even parameter values, ensuring that secrets are never shared with the model. Personal information is redacted. So we're just going to take a look at that. So we're in EmpowerID Identity Fabric, the experience shell. We will go and launch the AI assistant to chat with an agent. And I have a few agents here. Some of them are using they're our agents in EmpowerID Identity Fabric. Some are discovered agents that we've wrapped to govern, like this one coming from Azure Foundry, or they could be coming from AWS Bedrock or Google Vertex. In this case, we're going to do a quick example of an SAP Security Analyst agent. And it can analyze an SAP S/4HANA system in this case. Here are some of the things it can do, obviously, is it can check license posture, critical role holders, see who's risky, see why they're risky. We are going to do something just for fun. We're going to say, this is a demo system. So we want to create 5 risky users. We'll make them famous villains and assign them lots of risky access. Now, the agent is authorized by the policy decision point, which is OpenID auth It is fed this authorization from a graph Neo4j system we call the membership service. And that's where the relationship between MCP servers and their tools, agents, the delegation of an agent to a tool, and the delegation of a user to an agent resides. And that information is fed in for runtime authorization decisions at the policy information point for our ABAC PDP. So I'm going to ask it to create some risky users, try to make them realistic, and we'll just record what happens here. So now we're running the agent. The agent we can see what it's doing. It's in the planning phase. When you create an agent in EmpowerID Identity Fabric, you can pick which model provider you want. In this case, we're using GPT. What model, what level of intelligence, and that controls how many turns it does and all of that. In this case, this one is a level 2. It's pretty smart. It's not a level 3. The agent we can see is executing now. It has 80 available tools that have been delegated to it. And it's using the tools at this time. And looks like it's searching for roles. It's probably looking to see which roles are risky that we could add these users to. It's now searching for users. So we'll let it do its thing. Now, in the case of EmpowerID Identity Fabric, the governed execution, it's going to generate, of course, the mission. It's going to then validate on each execution that it's not going outside the boundaries of the mission. Now, one thing we'll notice here, interesting, we actually have a technology we created called Contract Defined Autonomy, or CDA, where the tools have metadata that enforces how they behave, which tools are risky, which ones should be redacted, enforcing never letting the model get the secret. So in this case, it knows I'm doing a risky action, which is creating many records at once. So that tripped the CDA policy, which is config, to say it's high risk and it needs human in the loop approval. And the CDA supports bulk approval, so I don't have to get approved one by one. And it looks like it's showing me what it's proposing. It's going to create Lex Luthor, the Joker, Thanos, Ultron, and Dr. Doom. which is interesting because the movie's coming out soon. So I'll give it a password. And the reason it's asking me to give it a password is that we have CDA enforces that the model can never receive the password. So it's interrupting it here. It has a special form. It knows when it needs to be prompted to share a secret, show a secret, or create a password. So it's never going to share with the model. And I have to have human in the loop approval, which will go for the governance. I'll approve it. And now it's going to continue executing. Of course, on the back end, we'll see it's validating everything, creating extremely detailed audit records of not just the authorization decision for the tools, but also the after effects that we enforced a one-time usage effect receipt. We burned it and it recorded what happened, and it hashes each of those proof receipts with the previous, so they kind of like a blockchain, so they can't be broken. So it looks like, okay, it's gone to the next one where it's going to do bulk role assignment, which of course the CDA metadata is going to say that's risky, and that needs human in the loop approval. Again, that's configuration, and I can do bulk. Looks like it's assigning them to a bunch of risky access for our demo scenario. I will approve it. And now, of course, it's going to continue executing. And it's going to show me a summary. So let's see what it did. It created our risky users. They all succeeded. That's great. It created as dialogue users with a validity. It assigned them to risky roles. And of course, it's repeating to me that no plain text password was shown, stored in the chat. It was redacted and governed and never shared with the model. And now the most important thing is that this was a governed execution process based on a mission. So we can go and review the run and see the proof that would not be possible under normal circumstances with just a regular MCP gateway or authorization approach. So this is the run. So every agent run is going to produce a run record and proof, which is JWS signed. So I can see here, this is the agent initiated by Patrick. It can be part of a session if you see multiple runs in a session. And we can see here the human explanation that it performed 13 operations under the delegated authority of Patrick. Every operation was executed at runtime and matched to the recorded intent. So that's important. That we can't hack it by sending it what looks like a valid tool call and changing the parameters, as in recent attacks, but it's going to validate that. 2 external changes were recorded or effects, 41 of 41 signed receipts with a verifiable proof. We can see the governed execution chain, that it validated that delegation from the PDP that was stored in the graph. Agent selected 13 operations that were permitted within the mission boundary. The PDP made 34 policy decisions, 13 effects were executed, and we can capture my initial prompt. And here we see the mission was recorded. It was based on delegation authority from Patrick, which we could go look at. The boundary of the mission in this case is just all the tools that the agent was authorized to use. And then we can see some evidence of that and the authorization decisions and the technical details if you'd like. Did the execution match the authorization? So this is the critical thing. Are we enforcing that what was executed, the governed execution, matches the mission parameters? And it will validate all of that and fail it if it doesn't. Is the evidence complete? Looks like the evidence was complete, and we have all the receipts. The custody is the before the effect, and then that's validated against the execution receipt to ensure that what was authorized, which is the custody, is actually what was approved. And you can look at the signed receipts, shows the delegation that allowed it, the initiator's identity, the agent's identity, the authorization decision, if there was human in the loop approval, all the signing. And now, of course, we can go and look and see the inputs that were provided and whether or not they were inferred by the agent. They were default values coming from CDA, or if it was something provided by the end user. So you even know what the agent guessed on or inferred in what was provided by the users. And now at this point, you can export the evidence if you need to for an auditors, or let's say this is a process like onboarding a contractor. And it did a great job this time for a complex process. All of the called the policy engine, figured out the birthright, did the naming convention. The last thing most large customers want is something like onboarding contractor to be non-deterministic and invented every single time. So what you can do is you can get a good run that you like that really worked well. You can say this was a good one. It matched all of our AI laws of identity, and therefore it's available to be certified. And what certification does is it takes that run and generates a deterministic graph workflow that our orchestration engine can execute. It parameterizes whatever the inputs might be to make it reusable and generic, and then it publishes it as an MCP tool. So now you could say, if this were the onboarding contractor, you'd have a graph workflow where all the tools would be workflow activities. The inputs would be mapped, and you could have an MCP tool. So now your agents, when they onboard contractors, would have a deterministic process. And you would certify it and publish it, and then grant the agents access to it. So again, just kind of a recap, we did a pretty complicated process. An agent was validated at runtime by an OpenID auth-send PDP. We had governed execution, which generated a mission and enforced the mission. It generated JWS signed proof. And of course, if we like the run, we can come back and we can publish it so that now we turn a non-deterministic process into something deterministic. And that's just a quick overview. I hope this was helpful. Thank you.